Hello, my intrepid coders. Welcome to today's video where I'm going to be covering requestAnimationFrame and how its surprise intertwines with web animations. Whether you've done them before or not, no big deal. This is going to be a great tool to have in your tool belt, right? So this topic is kind of kindled into the previous two videos that I made on debouncing and throttling. Both of those concepts were about trying to optimize performance on repeated actions in the same way that requestAnimationFrame is going to show us today. Now, the visual on those is very obvious. The visual on this one, this demonstration, it may not capture all that well on my screen recording in OBS, but know that it is indeed being optimized in the background, even if visually it doesn't seem to be doing much difference. Now, those debouncing and throttling tutorial videos I have, which will be linked in the description down below, along with other things, were spawned by a student's question in our Discord channel. They are a community member, and they're paying $25 a month for access to our front-end and back-end courses, which combined is our full-stack development program. They also have access to my standalone advanced React course that takes you from zero to hero. And I'm currently in the works on a database and TypeScript standalone courses as well that expand beyond what our full stack program teaches you in that crash course way. So if you have interest in all those courses, access to our Discord, custom content made for you like this, then you should consider joining and checking out that link down below. And you can just feel free to keep watching these videos, like, comment, subscribe, and just support us on YouTube, and you'll get tons of free stuff here anyway. But yeah, so with that in mind, just like my other videos, I'll have a Codepen linked down below where you can grab the HTML and style sheet of this particular little application here if you want to follow along with the code. Otherwise, feel free to just watch the video as is, grab the Codepen afterwards, and just try and internalize, learn, and figure out what I'm talking about and code it yourself later. If you'd like to follow along, pause the video, grab that stuff, and get ready. So the HTML is fairly simple: button, couple divs, linked style sheet, linked app or script-sourced app.js, no problem. The style sheet, I found a lovely article that taught me how to do hexagons in CSS since I thought the square was overdone. Plus, we all know that hexagons are the bestagons. Get in the comments if you got that reference. And yeah, so I made some hexagons, and our goal is going to be to spend these suckers and see what we can do. I should have this running in the browser at the moment, so let's go ahead and take a look at the beautiful application. I'm already zoomed in and all that kind of fun stuff, and currently the button does nothing as I have no code. But nevertheless, we have that vaporwave theme, as I always like to do. I mentioned requestAnimationFrame, and it has great adoption across browsers at a global unprefixed 95%, which is awesome. Anything else where you have these edge case scenarios, you can just use a polyfill for, but pretty much all modern browsers are going to allow you to use this API as well as its corollary, cancelAnimationFrame. Yeah, so it is a more efficient way of running script-based animation compared to traditional methods using timeouts. Surprise, surprise, right? So why do you need this? It's an excellent tool that lets browsers optimize screen redraws and updates, which provide smoother animations and ensures efficient rendering, right? So browsers can optimize the animation, ensuring that smooth frame rates and reduced jank. The whole thing about frame rates is if the frequency changes, like it may with an interval, for example, if the browser can't keep up with redraws, our eyes will notice the frequency change, and that will look worse to us than a lower frame rate that's at least staying consistent, which is why staying consistent is a big deal, and this API can help us do that. This will also work in conjunction with the browser's refresh rate, which prevents unnecessary calculations, again tying into the concept of throttling and debouncing from my previous videos. On top of that, battery efficiency can be a big thing depending on what kind of app you're building. So this API allows us on devices with varying refresh rates to give the best performance without draining their battery. For example, if the browser tab is no longer in focus, requestAnimationFrame will actually stop performing animation operations, which an interval will just keep going forever, thereby making this even more optimized when we're trying to not hog somebody's CPU performance by our spinning hexagons on a page, for example, right? So again, this allows the CPU to not get overburdened processing excessive rendering tasks, which allows it to run our animation stuff side by side with other operations without competing against each other or burning out the CPU. So again, it's going to be difficult for me to display this in the browser on a recording, but nevertheless, we're going to take a look at the code here together, and we now know some of the benefits, very tangible benefits of running code with requestAnimationFrame. So let me show you what it looks like without it first, and we'll see if visually we can make it look crappy. And then from there, we're going to just kind of build up to AnimationFrame, and you'll see the code itself is simple to understand. Let's go ahead and grab my add hexagon button from the DOM here by running our document query selector. I think I had that as add hexagon camel cased and not hyphenated. Let's double check. ID add hexagon class container. It's a class is the container I need. So we're going to say grab container, hey document, go into the DOM for me, and please find that container class div. You should be the only one. And then from there, we're going to add an event listener to our button of type click that will run a function. Ooh, I can't type today. My fingers do not want to work. You know, get in the comments if you just ever have those days where you are so stoked to get coding, your mind, like the gears in your mind or the pistons are turning, but your fingers just don't want to work. Like I've done several takes on this video so far with editing my script and seeing what things work and don't work while I'm recording and watching myself back. And after like 7 or 8 takes, my fingers are still not wanting to type. I just cannot get them warmed up today. Again, get in the comments if you got days like that. And if you have anything to fix it, let me know. All right, let's make that hexagon. We're going to do a hey document. Let's create ourselves a little element here of a div element, because the way I have my CSS set up is that any divs inside a container should be styled as hexagons, and that's what this represents. So no class naming required. So we're going to simply say, hey container, I wish to append a child of the hexagon div to you whenever I click this button. This is enough to make my beautiful hexagon grid appear. Look at that. Hexagons are indeed the bestigons. So we had them all appearing here. Now it's time to get them spinning. And let's say we don't know what requestAnimationFrame is. We might be going, okay, we have a timing function. So I need to spin these things, and I want them to be spinning on some kind of interval that looks kind of smooth. So we might say, okay, that makes sense. Let's set ourselves an interval, not a timeout. We're going to set an interval that's going to run some code. And I want it to run, let's just take a guess here, at 100 milliseconds per second. Every 100 milliseconds, this interval is going to run. I am going to use a variable that will be locally, uniquely scoped to each hexagon. And what I want to happen is this rotation variable will simply be increasing, let's say, by 10 every 100 milliseconds, and from there, I will use an inline style on each hexagon and simply apply a transform value in CSS, or property in CSS, with a value. We'll do a template literal to do some interpolating, and we'll do a rotate degrees. How many degrees, you might be wondering? Well, every time the rotation value changes, we're gonna spin this hexagon here. Now, these are just values that aren't going to look good because I'm just goofing off here, right? I'm testing these values, and it looks jank, and it is jank because, well, I didn't pick a great rotation. I picked 10 degrees every 100 milliseconds, right? So it doesn't look very smooth. We can actually smooth this out, and if you do some research on your own, you will discover that it is about 16.67 milliseconds is about 60 FPS or so. This will vary on people's computers, browsers, CPUs, blah, 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 but this is like a rough estimation to keep in mind. So if we can just do 1 degree every 16 milliseconds, we will see a much smoother animation right out the gate. And there we go. As you can tell, this is already much smoother. So like I said, it's going to be hard to really make this look crappy. I think if I go to like a mobile view and ask it to do a low-end mobile throttle, I mean, looking at my OBS monitor over here to see what it looks like. I mean, it looks kind of choppy, I guess. Maybe that's just my mind thinking it is. Like, I think the more I add, obviously, if I added like 1 million of these to the DOM, that'd be a lot of animating, and it probably wouldn't look very good. And that's where we'd start seeing some of like the more jankiness come into play. But basically, every single one of these is stacking an interval, which we also know isn't a terrific way to do this either. Okay. You know, they used to not have this warning that CPU throttling is enabled because I've shown students in the past how to do CPU throttling in your browser's dev tools, and I forgot to turn it off. And then I would sit there and wonder during a different webinar or classroom of the day where I'd be wondering why my code is running so slowly and so poorly. It's because I forgot to turn off throttling. So I'm glad they have these warning signs here now that, hey, by the way, you're doing something kind of stupid here. CPU throttling is enabled. All right, so even on a crappy CPU, it's handling it okay, but we know that we're just taking up more and more and more of that CPU the more animating we do here. If you had any kind of SVG with calculations and shadows, it gets worse and worse and worse as that goes. So without any throttling in mind, let's go over and look at our code and say, okay, we know this is going to be about 60 frames per second, but we know that we can actually leverage that with the browser's native refresh rate and not have to set an interval for every single one of these hexagons, as we know there's a much better way to do so. So we're going to call this the old busted, and I think I labeled it as such inside of my Codepen as well. So we're going to get rid of that because that's not how we're going to be rocking our new hotness solution. So here is finally all this talk about optimizing and animating and all that fun stuff to show y'all what this code looks like. We're going to make a function called animate, and we're going to call that function animate right down below like that and call it a day. And what I'm going to do here is simply add the rotation value of 1, just like we did in my interval code. From there, I will also tell my hexagon, and what am I doing? I can just copy and paste code, bro. I'm going to take the time to rewrite this. I could have just rewrote it differently. There we go. Where I'm going to, transform that hexagon by 1 degrees every time in the sync browser animation. And here's where we're going to finally call our window requestAnimationFrame API. This can take a callback that says, hey, run our function to animate. And what we're going to do is we're going to pass this in recursively, which is actually a very common practice here, right? This gives us an infinite loop of rotation by leveraging requestAnimationFrame, passing it what we're animating, aka this portion here, as our callback, and this will simply be stacking recursively now for us, and again, being optimized by the browser's window. From there, we can also, if we noticed here, if we know some TypeScript, it returns to us a number. So if we need to cancel the animation, we can actually animation ID, do something like that, or frame ID rather, I think is what you typically called, or like rec frame ID. We get a frame ID, and this rec frame ID has the ability to be canceled via that cancel animation that we saw over here in can I use. So cancel animation frame is the method to cancel it, and you pass in the frame request ID into it as an arg. So if we wanted to cancel it, we would just do cancel animation frame and pass in that value that we got from right above. So if I stop button, it's very easy to do so, which of course would also be kind of annoying on setInterval, but this is much easier, which, setInterval works in a similar way. It returns an ID. But yeah, just wanted to point that out, even though I'm not going to use it. But there you go. What I was trying to say is we pass in animate our function recursively in the requestAnimationFrame, and voila, we now have some beautiful spinning hexagons that have no issue whatsoever. Now, this might be my eyes and brain deceiving me, but these already look smoother than what was previously on the screen with my set interval. And I wonder if we notice any kind of difference if I refresh it on a low end. Well, it's taking forever to refresh because the networking is being throttled to a low end device. But if I add a bunch of these hexagons, again, it's hard to visually see. It's hard to visually see if they are actually slowing down or getting clippy compared to the set interval solution. But nevertheless, we know that we are way more performant doing requestAnimationFrame than we are not. So, try adding 1,000 with the for loop and seeing how it goes. But nevertheless, this is as simple as it needs to be. So again, while setInterval runs the callback at regular intervals, requestAnimationFrame ensures the callback runs before the next repaint, providing a smoother animation experience. So we can often visually identify smoother animations with requestAnimationFrame, especially when multiple animations are in play, or especially on less performant devices. And then the fact that requestAnimationFrame can call itself recursively, like we see here, means we have the power of continuity, right? It allows animations to remain fluid and uninterrupted, unlike setInterval, where you might face the risk of stacking too many calls and too many things, which could break an animation's smoothness, right? So this recursive pattern gives us control and lets us decide under which conditions to continue or break the animation loop. And then, like I said, you also have the ability to cancel the animation loop very easily, and a specific one by just canceling its requested frame ID. So yeah, I hope this deep dive will be useful at some point in the future. Or if you came here and you've never done this before, you now have a better way to animate things in your browser, right? We've shed some light on its power and how we can harness it. to have impeccable animation. So as always, your questions and feedback fuel our content. Do all the YouTube things, like, comment, subscribe. If you have interest in learning full stack development and some advanced React things and eventually some database and TypeScript stuff, those things are part of our full stack course, but I'm expanding their content further, and it's to the point now where they need to be their own individual courses as well. So yeah, until next time, happy coding and happy animating.